Okay, in 7.3, we're looking at applications of normal distributions. Number 4 basically was having us find the probability that some random variable is bigger than 65, given that the mean was 50 and the standard deviation is 7. And so if you're using your calculator or if you're using the charts you'd have to always go to the left. 1 minus to the left, and this number would be found on the charts, and you would get 0.01606. You could also look at your z-scores and put 65 minus 50 over 70, and you're looking at a z-score bigger than 2.14, and again 1 minus to the left, and you get 0.0167. The other thing you can do is use your normal CDF. You're looking at it being 65 and bigger, so 65 to 1e to the 99, the mean and the standard deviation, and you'd get the same answer. Now in number 10, we're looking at in-between values. So what we could do is we would take the probability that x is between 40 and 49. That's the same thing as saying the area under the curve to the left of 49 minus the area under the curve to the left of 40. If I put this into my chart, I find these numbers and this number. Keep in mind, I would have to use z-scores to find these in the chart, or as I did with my calculator, I used normal CDF and found the probability to be 0.4432 or 0.07656. Subtract the 2 and I get that number. Now if I am looking at z-scores, this is what I'm looking for. I'm looking at the probability that z is between these two values. And I use my z-scores. One, it helps me to remember the z-score formula. And I get that I want the z to be between negative 1.43 and negative 0.143. If I draw it out, this is the probability that I'm looking for. And in using my normal CDF, I would have lower bound, upper bound, comma 0, comma 1, and I would get this number. Now, technology answers are different than the charts. These tend to be more accurate. So if you do use the charts and or the calculator and they're slightly different than the charts, you'll still be okay. You have to look at the one that's closest to that. Now in number 14, this was again assuming that you have a random variable x. It's normally distributed with a mean of 50 and a standard deviation of 7. Find the 90th percentile. Now what that means is if I'm looking at this normal curve, I need to find the x value that gives me all the area to the left being 0.90. Or I can look at it finding the z-score. Now if I use the inverse norm with the z-score, 0.9, 0, and 1, I would get the z-score to be 1.28, the inverse norm. And then I would rearrange this and find x. Here's my z-score times my mean, or my standard deviation, plus my mean to get my x value, which is roughly 59. Now this problem is about the Wendy's drive-thru. Fast food restaurants spend quite a bit of time studying the amount of time cars spend in their drive-thrus. Certainly the faster the cars get through the drive-thru, the more the opportunity for making money. In 2007, QSR magazine studied drive-thru times for fast food restaurants, and Wendy's had the best time with the mean time spent in the drive-thru of 138.5 seconds. Assuming drive-thru times are normally distributed with a standard deviation of 29 seconds, answer the following. And part A is telling us what is the probability that a randomly selected car will get through the Wendy's drive-thru in less than 100 seconds. So again, I'm looking at the probability that some random variable is less than 100. I'm looking at my z-score, 100 minus 138.5 divided by 29. I get this as my z-score using my normal CDF. I would get that my probability is 0.0922. And I put it in this way so that I can get what my probability is. Now, what about if we have on part B, what's the probability that a randomly selected car will spend more than 160 seconds in the drive-thru? So again, I find my z-score, and I'm looking to the left if I use my charts, 1 minus to the left, or I could use a normal CDF, 0.7414, 1e to the 99, mean, standard deviation, and I get about 0.2292 is the probability that they will spend more than 160 seconds. Now, hint, you don't have to put in plus or minus 1 times 10 to the 99 or plus or minus 1e to the 99. If you're using z-scores, you can actually, since the mean is 0, and 3 standard deviations either way is about 99.7% of your data, you can use numbers like plus or minus 5 and get the same results and not have to put that value in. Something to remember. However, this only works if you're looking at z-scores. Now, part C says, what properties of cars spend between 2 and 3 minutes in Wendy's drive-thru? Now, every piece of our data is in seconds, so we took 2 minutes and 3 minutes and converted it to 120 seconds and 180 seconds. Now I found my z-scores, just to get into the habit of being able to remember my z-score formula, and I want the probability between these two z-values. So I draw what I'm looking for, and I want to know what this area is. So I do a normal CDF between these two z-values, 0 and 1, and I get the probability to be 0.6620. Part D says, would it be unusual for a car to spend more than 3 minutes in a Wendy's drive-thru, and why? So more than 3 minutes is greater than 180, so I'm looking at my z-score being greater than 1.4310. Again, when I put this into a normal CDF, I get this to be 0.0762. Now, we're looking at roughly 7%. Because 7% is bigger than 5%, it is not unusual. Now, the reading rates of middle 95% of the 6th graders, we need to find out what those scores are. So using this drawing, I can either find the z-score or I can directly go to the x-score. Now keep in mind the middle 95%, since it's symmetrical, you're going to have 5% left that's divided equally in here, so that's where I get 0.025 and 0.025. If I'm looking at an inverse, so now what I'm looking for is trying to find either the z or the x values in these two range. So what I've got here is I can use an inverse norm, and I want to go 95% and 0.025 from 0 to 1, and I get this z-score. Then I would take the z-score times the mean, the standard deviation, plus the mean to get my top value of 172. Or I could use the inverse norm, 0.975, the mean, the standard deviation, and get directly here. Now, if I want to find this x2 value, I can use for z-scores 0.02501, and I get my z-score to be negative 1.96, times the standard deviation plus the mean, and I get my lower score to be 78. Or I can just go directly through 0.025, the mean, the standard deviation, and get 78. So the cutoffs of unusual times are between 78 words a minute and 172 words a minute. Now you should be able to do your 7-3 homework.